Carbon, hydrocarbon. Allotrope, the allotrope of carbon. Student, let's explain the word allotrope. What's meant by allotrope? Allotrope means an element. Of this element, it can have several different molecular arrangement and different structure. Repeat, an element may have several different molecular arrangement and different form of structure. As example in diamond and graphite. And now let's look onto the example of this type of element, carbon. Allotrope of carbon. Carbon can have, they both are the same element, carbon, but they can have different molecular arrangement, can form into a diamond and into a graphite. Diamond is a covalent network of carbon. And graphite is also a carbon, but they arrange differently. They form into a flat parallel layer. And I'm going to explain detail. Let's see diamond. Diamond is a covalent network of carbon. What's meant by that? Let's look. If you look onto the diamond, diamonds have a very funny rigid structure. This is called the covalent network structure. If you look onto each carbon in the center, they will be all surrounded by other 4 carbon. Let's look onto what do I mean by that. Look at this carbon. Can you see this carbon? Carbon have 4 bonds. 1, 2, 3, 4. So look at this carbon. And now this carbon, they are tightly connected to the neighbor carbon. And this carbon also connect by 1, 2, 3, and at the back 4. And so it's also connect to the neighbor carbon. And this carbon also connect to the neighbor carbon. And as the neighbor carbon further on, and as to the neighbor carbon. So they are in a very total rigid structure. Each one, they are bound by the 4 neighbor. Each carbon, they are bonding by 4 neighbor. So this center carbon, they all have 4 other carbon, they holding them together. So they form into this. How is this shape we call it? This shape, we call it a tetrahedral shape. Tetrahedral shapes that we mentioned earlier. These 3D shapes. And because of this bonding, each one bond by 4 neighbor carbon, so they make it into a very rigid covalent structure. They make it into a total rigid covalent structure. And that's make diamonds to be the hardest crystal on Earth. So nothing harder than diamond. And diamond as a carbon, and they do not conduct electricity. As we expect, non-metal, they do not conduct electricity. So keep this in mind. And now let's look onto another example. How about graphite? Graphite is a very different structure. They are arranged in a flat parallel layer. A flat parallel layer. What I mean by flat parallel layer? Look at this structure. You see, they are formed into one layer, another layer, So instead of forming into a tetrahedral, they form into a layer, a sheet with another sheet of carbon with another further sheet of carbon. So they form into a many different sheets of carbon together. And look onto the bonding. Choose one. Look at this carbon. See how many bonds? 1 bond, 2 bond, 3 bond. Look at this carbon. 1 bond, 2 bond, 3 bond. And see, they are together form into what shape? They form into a hexagon shape. 1, 2, 3, 4, 5, 6. This is a hexagon. And this hexagon bond with the neighbor hexagon. And with the neighbor hexagon. And they all form into a layer. And within this layer, they quite rigid. Just like as covalent bond, they are rigid. So, but when you consider between one layer with another layer, that is the layer with another layer, the layer with another layer, they are a total different story. That is a weak dispersion force. That is a weak dispersion force. What is weak dispersion force? The weak dispersion force is a very weak force. So they can one sheet of carbon can easily slide past with another sheet of carbon. So between layer, there is a weak dispersion force exists. So they easily slide past one another. So this makes the graphite soft and slippery. And that's we made it on for the pencil lead. Look at pencil lead. The pencil lead is made of graphite. So this graphite layer can easily scratch and deposit onto the sheet of paper. And that's how the structure lies. So you can compare the graphite with diamond. Another feature, graphite have another feature. Look, carbon have 4 electrons. Remember? 4 electrons. Now how many electrons are there? 1, 2, 3. Where's the other electron? These 3 electrons, 1, 2, 3 electrons are bonding. But you have one more loose electron, a loose electron. This is a delocalized electron. This delocalized electron can free to move. When an electron free to move, what does it mean? Free moving electron conduct electricity. So carbon, this graphite, is the only non-metal. They as an exception rule, this non-metal, they conduct electricity well. And so if you cut a battery in the middle part, the black color part, that is made of graphite. Why they use graphite? Because they have loose outside electron and conduct electricity. So now you can compare the allotrope of these two types. Diamond, covalent network. They form into they bond by 4 other carbon, form into a tetrahedral shapes, and they are a rigid covalent structure, form the hardest crystal on Earth, and the electron are localized, unable to move, non-conduct electricity. Look onto graphite. graphite form into a flat parallel layer. So the carbon covalent bond by 3 carbon and form into this hexagonal arrangement, flat layer. But between layer and layer are dispersed force. These dispersed forces are weak, easily slide past one another, and that makes graphite to be a soft, slippery substance. They use it in the pencil lead. Also, remember, graphite, they have one loose outside electron, and it conducts electricity well. Another allotrope fluorines called the buckyball. This is a soccer ball but in a molecular form. It's a not natural soccer ball. As you can see the shape, this is made of 1, 2, 3, 4, 5, 6 against 1, 2, 3, 4, 5. So this is a soccer ball shape, and also is a type of allotrope.